Anyone else agree, or does anyone disagree with that? How about at your location there in Poland? Would you have considered gemcitabine single agent?
I think I would probably prefer monotherapy by gemcitabine.
You would have leaned more towards gemcitabine
Yes.
versus FOLFIRINOX in this patient.
Rather gemcitabine in this case.
Okay. Again, single agent
Yes.
gemcitabine as an option. Right. How about any other at the UK, at your location, Dr. Salim? Do you know what your colleagues would have?
I think both are equally good, really. I mean, it's quite difficult. It depends on how you assess the patient, really, how fit the patient is. I mean, gemcitabine is an equally good option, really, but you don't use enough paclitaxel a lot, really, so either it's FOLFIRINOX or gemcitabine.
Is this a case now at your location where a clinical trial would be an option in a case like this?
Yes, but I also understand that this patient was traveling, was not local, so monitoring and a lot of clinical trials.
Of course,
Patients who
of
have
course.
MI and all this
Yes.
sort of
Yeah.
conditions. So.
Yeah.
I just would like to
Fascinating.
comment that because you mentioned if in 1 month the patient was fit, in this particular protocol it's at least 6 months. This is exclusion criteria number one. So patient wouldn't have been fit even if he didn't travel.
But we're,
For this
yes,
trial,
so
unfortunately.
again, we're using the case to illustrate, just understand certain points, and of course, pertaining to the specific trial, we do want to be sure that there are clarities and clarifications on eligibility criteria and what's required for patients to be considered for Maestro. So appreciate your comments and to bring up those points, which I think are important, so everyone is on the same page. And this patient has been was treated, and you had some evidence of response to therapy.
Okay, so here's the further course. We started at the end of April with the treatment. This is the decline, the rise of the tumor marker, and this was the point we started actually with the combination. Also in the time before, remember he had already the biliary stent placed. He developed some symptoms of gastric outlet obstructions, and we decided to put in a second stent, a metal stent in the duodenal, in the proximal duodenal. The patient could eat thereafter again. We started with gemcitabine plus nab-paclitaxel in a somehow modified way, since the patient was traveling during chemotherapy every 2 weeks. And the patient had a continuous decline of the tumor marker from 6,000 to 1,000. And actually, at this point, we did the restaging. The tumor marker went really impressively down, and this patient had achieved a partial response. Unfortunately, the patient decided at that time to stop the treatment, to go back to Kazakhstan, and well, to wait for 6 or 8 weeks. And when he returned to us at the end of August, September, he had again problems with gastric outlet obstruction, and we saw actually at that time what was expected, of course, a progression of the tumor, and the patient also died quite quick I think in November. So I think this was my last slide. Yes.
I have a quick question clinically in this type of scenario. So the patient was treated and then had some evidence of response.
Yes.
Let's say the gastric outlet obstruction was related to progressive disease.
Might be, yeah.
Is this a patient or a scenario where second-line therapy is something you would consider?
Well,
And in 2014, how's that changed from 2013 or 2012 in terms of second-line treatment options?
well, the first point is never stop a winning chemotherapy. So never in pancreatic cancer. And colorectal, that's something else, but pancreatic cancer, it doesn't make sense. The patient really insisted to go home to Kazakhstan. So what if he might come back after 2 or 3 weeks, we just would have continued with the treatment again. And at that time when he came back, he was not in a good shape anymore, and we had really problems to get him back to Kazakhstan.
Yeah. So is this a scenario where second-line treatment is considered at your sites? How about in Hungary and
I think we can do gemcitabine with other drugs. With
a doublet
yeah,
in
yes,
a...
with CDDP or with 5-FU, with leucovorin.
What would have your first-line treatment have been in this case?
In this case, I think I do gemcitabine.
Gemcitabine? And then on progression, consideration of adding a second agent to that on progression?
I think that best supportive care and to put the stent as much as to help him without symptoms, without suffering. This is the first. Best
Of course.
supportive care.
Of course,
After that, we'll see if it's good, give him treatment.
of course.
Agents are, of course, we're talking only about single agent as a gemcitabine, but at the beginning, to control the symptoms, as a stent or everything what you have there, and best supportive care.
So the overall management,
5 months,
Yeah.
has he suffered here?
well, that's always the question, right? What's the plus and the negative of every treatment we choose? If we put a patient...
It's not easier treatment, I want to tell you.
Correct.
It's very difficult
Yes.
medicine.
And I think
Treatment.
that's
It
one...
has a lot of side effects.
I think that is one thing we have understood at each of these gatherings is really the understanding in the practice, in the clinic, when you are managing the patient. The side effects, we all know FOLFIRINOX, we know the published side effects and profile and things. But clinicians have also shared with us, as you've mentioned, gemcitabine alone is chemotherapy. Gemcitabine nab-paclitaxel is chemotherapy, has also side effect profiles. And the quality of life obviously has to be evaluated and weighed with all these options. So your points are very well, are important because each of these treatments certainly has side effects. And nothing is without zero
Yeah, of course. Gemcitabine is less,
side effects.
less
Of course, yeah.
according to the other one.
Right.
But of course, we are talking about gemcitabine as first treatment as single agent. But we see that we have a patient here very with performance status of 2 or 3, right?
At that time, yes, definitely.
Yeah.
Upon
So
progression,
At the
we're
end,
talking.
yeah.
You have bilirubin 10, you have to put the RCP and to put the stand and to see what's going with the patient. After that, I think you can think about the chemotherapy. But first,
But these would be coming back to the discussion about performance status and what types of symptoms can be addressed to improve performance status versus what are related to rapidly progressive
you can be,
disease.
excuse
You know,
me, but
can
you can
things
be
be
fatigued,
improved?
you can be want everything, but it depends how many times. If you're vomiting twice a day, it's okay.
Right.
If you are, you can run, you can walk for 3 kilometers, it's okay. It depends how it's influence your life. You
Yes.
understand me? This is
Okay.
the point.
But some of the criteria
It's
are,
dangerous. It's very dangerous what we are talking about this case.
the cases, correct, had a lot of complications.
Yes,
with
but-
the patient.
But my point is actually, we have problems we can manage.
Yes.
Cholestasis, gastric outlet obstruction, infection. This is all manageable. And this is also my point. If you can manage this, then you can treat the patient. And this patient, he had a response. Without treatment,
In 5 months.
without treatment, actually, he would have been died at that point of time. So complications due to the tumor are treatable. Some of them are. Of course, fatigue is not, but some are. And if you can treat those complications, then you can also start a chemotherapy, also quite modified or intense chemotherapy. That's my point.
You think that it was better due to the gemcitabine or because of the other treatments?
Well, he has a combination, so we don't know. We just saw the response, actually.
Great, thank you very much. So, Martin, would you like to present the information on TH302 and the phase 2 information? Yep.
So we will go back a bit to basics. I'm trying to give you a bit of an idea about how development of TH302 was initially looked like, and then some clinical data from the early development. We won't go too much into details because the focus of this meeting is slightly different, but we would like to give you at least some idea about the background of TH302. So in the 90s, there were a group of folks in California who really tried to ask the question, what can we do to improve care for patients with cancer? How can we develop new and effective compounds against cancer? And of course, then you're asking the question, okay, so what are the principles that keep cancer cell being malignant, and what are these principles that can be targeted, which are druggable? So initially, this group of researchers were targeting at metabolism, because metabolism is one of the key features of cancer cells, which makes them different from normal cells. And if you look, for example, into that, you will find some of the early developers of TH302 being involved also in a compound iphosphomate coupled to a glucose modified molecule, which aimed at targeting of increased uptake of this compound, because cancer cells have an increase of energy anabolism. But these folks also realized that there might be more than just metabolism. And one of the targets they were looking at was hypoxia. So why hypoxia? Well, some of you may know this famous cartoon from Bob Weinberg, which was renewed in 2011 about the hallmarks of cancer. And if you look at that, you won't find hypoxia there. Yeah? It's not one of the 10 named hallmarks, but if you further look at the details, you will find that some, more than one of the hallmarks are closely linked to hypoxia. I think all of you know that hypoxia is really one of the constant features of tumors. It varies from tumor entity to tumor entity, so there's tumor entities who have greater degrees of hypoxia, others that have less. But hypoxia is also very clearly one of the factors that drive the prognosis of the patient. And that's illustrated by many clinical trials, preclinical investigations that tried to link the degree of hypoxia to the prognosis of patients. And that's just highlighted here by 3 different graphs comparing the degree of hypoxia, high versus low, in sarcoma, head and neck cancer, and cervical cancer, and correlating that to prognosis. And in all these cases, it's very obvious. The greater the degree of hypoxia, the worse the prognosis. So there's many mechanisms resulting in this decreased prognosis of patients or tumors with higher frequency or percentage of hypoxia. But it's very clear that this is one of the principles that are worth targeting. So how would one target hypoxia with a drug? Well, what these guys used as a screening assay was an in vitro assay, where they took a cell line which easily tolerates decreasing the level of oxygen in the tissue culture system to 0 for a couple of hours. And they then put all the compounds they were screening also through this assay. And for TH302, the result was like this. So what you see here, if you look at the red curve, this is normal air. 21% oxygen or so. And you get a 50% inhibition of the cell growth here at roughly 10 to the minus 4. This is molar, right? And gradually decreasing the percentage of oxygen in the air increases the sensitivity of the cell line to cell death or to the compound for, well, this is now here, if you go down to 0, this is 10 to the minus 7, so this is nearly 3 logs of concentration. TH2 was one of the compounds which was showing up highest in this type of screening assay. So that was why they decided to move further on with this type of assay. So that's how it can be demonstrated how hypoxia can increase the in vitro efficacy of a compound like TH302. What about in vivo situations? So of course the next step is then murine assays. Okay. Classical system is to use human xenotransplants in mice. So this is what the colleagues did. They took a wide variety of human xenotransplant, transplant them into sensitive mice, and looked at the degree of hypoxia. Now, when I'm saying looking at the degree of hypoxia, this raises the question, how would you measure, how would you determine hypoxia? And that brings me back to one of the earlier slides. Actually, it was the second one. So one of the classical methods to determine hypoxia, and still the gold standard of determining hypoxia, is the use of an electrode-based measurement of oxygen levels in a tissue. Now, putting an electrode into a tumor or even into a patient is not a very practical procedure. So researchers always had looked for compounds that would be able to be a marker of hypoxia, for example, in terms of a biochemical marker. And one of these markers is pimonidazole. So pimonidazole is a compound, it's a nitroimidazole, that upon exposure to hypoxia is being cleaved, resulting in the potential to stain against the cleavage products in tissues. And this,
Sorry, how you take it?
so what you do is you treat the animals systemically with pimonidazole, and then take out the tumors and stain with a certain staining procedure. And if you choose the right conditions, you get an increased staining here. In this case, it's brown. It depends on the color assay you're using. That correlates with the degree of hypoxia in the tissue. So here's an example how tumors typically can look like. So if you have here, for example, a blood vessel, around the blood vessel you have a zone, an area of relatively high oxygen pressure. This is called the normoxic zone. And with increasing distance from the tumor vessel, from the blood vessel, the hypoxic fraction increases, which is nicely being seen here by the increased of stain. And in further distance, you result in a zone where there's even no oxygen at all, and where the tumor tissue has become necrotic. Now, this is one of the bases for much of the hypoxia research that's currently and previously being done. And this principle has then been used to visualize hypoxia in these murine xenotransplants. Now, this is such a typical panel of tumors, 12 tumors, different human xenotransplants, and you see different degrees of hypoxia. For example, here you have a tumor with strong staining, larger areas of hypoxia. Here, right lower corner, this is a tumor with only weak staining, smaller areas. And all degrees in between. Now, what would be the effect of a compound like TH302 postulated to be hypoxia activated in such tumor situations? And if you do the analysis of the tumor growth in these, exactly in these animals, you result in these curves. So if you again look at the left upper corner, untreated mice, tumor growth is visualized by the dark blue bar, and in the presence of TH302, tumor volume growth is much reduced. Now, if you compare that again, so these are the identical tumors to the previous slide. If you then compare, for example, let's take this tumor here with the lower degree of hypoxia, and here the effect of the TH302 in this animal system is quite low. If you take others, like for example this one here, compare it to degree of staining, it's not so high. If you take this one here with a larger area of staining, you again see a greater effect. So overall, with an increase, the summarizing information out of these murine experiments is that with an increase of the hypoxic fraction, you got also an increase in the tumor inhibition by TH302. So that is one of the key information that comes out of the murine evaluation experiments here. So how might that work? How might hypoxia activate a drug to be more active in a higher hypoxia? Well, coming back to the compound structure, let's look at this one here. So this one here is the structure of TH302. You find that the drug is itself composed, again here, of a nitroimidazole ring, and a second part of the molecule, which is called here the warhead. If we go one slide back, this is the description of the compound. The other part of the molecule is this one, this part here, and this is an isophosphoramide mustard containing a brome atom. So it's a bromo-isophosphoramide mustard. It's belonging to the group of mustard compounds like cyclophosphamide, bendamustine. Yeah. Exactly. Yeah. Now the big difference here to all the other members of that family is that if you put this drug into this compound into hypoxic conditions, one reaction is blocked, which usually prevents the generation of the separated bromo-isophosphoramide mustard. And the point is that in normal tissue, normoxic tissue, there is a standard, well, in any tissue, there's a standard reaction which leads to reduction of the initial product by 1 electron reductases, which is immediately catalyzed, for example, by superoxide dismutase, SOD, to the back original product compound. So by that, not allowing the generation of any of the toxic breakdown products. Now, in hypoxic conditions, this back reaction is not possible because of the lack of availability of oxygen, and this then leads to, after additional reductive reactions, to the break off, the spin off of the bromo-isophosphoramide mustard, which is the toxic product in this compound. So this is basically the principle by which TH302 is thought to be activated by hypoxia. Both breakdown products, or especially the isophosphoramide mustard, can be detected even in circulation in patients. So in the early phase 1 clinical trials, in the PK analysis, there was a very low degree of isophosphoramide mustard being measurable in the peripheral blood, below 1% or so. Yeah? So apparently, and it's currently not clear whether there's any correlation of these levels of bromo-isophosphoramide mustard in the peripheral blood of these patients with clinical activity or with tumor load, whether this is higher in patients with greater hypoxic conditions. This is not clear. But there seems to be something, some activity in these patients really be true. So that is some of the baseline information that is helpful to understand how TH32 may be activated and may derive its clinical activity. Based on these theoretical considerations, a phase 1 trial then was set up. And that was just a standard way a cytotoxic drug is being evaluated. So this was a classical phase 1 trial with a low starting dose of 7.5 milligrams. And TH32 was evaluated as a single agent with the treatment schedule you see here. Week 1 to 3 of a 4-week cycle was given. Eventually, a maximally tolerated monotherapy dose of 575 milligrams per square meter was obtained, resulting in a recommended phase 2 dose of 480 milligrams. Now, what were the dose-limiting toxicities in this trial? So that's described here. Basically, it was skin and mucosal toxicity. So that already turned out in these early phase 1, in this first phase 1 trial, that stomatitis, also rectal mucosa inflammation, and skin affectations, that were the dose-limiting effects in these situations. What about efficacy? Well, there were clinical responses observed in patients with melanoma, small cell cancer, lung cancer, and head and neck cancer. So, single agent. A single agent, yes. And it was not only at the highest dose, but also at intermediate doses observed. So that formed the initial basis for confidence to move on with clinical development of TH302. Just to give you an idea about the numbers, so for melanoma, there were 8 out of 36 patients. There was a dose expansion cohort that showed clinical responses, and if you compare that to the historical response rates with temozolomide or the DTIC, that is clearly in the same, if not in the better range. For small cell lung cancer, of course, that was also last line. It was 2 patients out of 10, and for second line head and neck cancer, it was 2 out of 8 patients. So this trial formed the basis for having confidence that the drug is active against human tumors and not just against one. It looks as if there's a broader activity activity in human tumors. At this point in time, I think we can stop here and move ahead with a quick video that highlights, that summarizes what I've just tried to explain about the mechanism of action. This is to be started how? Okay, thanks, Craig.
So while you're loading it, I'll just mention that we did put this video together to share with the sites to help explain the mechanism of action. Many of the sites have asked if we could share that with you, give you copies to share with patients if they have questions. Unfortunately, our legal department's very conservative and will not allow us to release the video, but we have, Gregory and Christine, I do think we have the handouts. Did we have the laminated handouts? Okay, so in your booklets, there should be laminated handouts that have been approved by our legal group. to have those discussions with your patients if they are interested in the mechanism of action.
Viewers are
already running?
prohibited from sharing or distributing its contents to any third parties. TH302 is under investigation and has not been approved for use in the U.S., Canada, Europe, or elsewhere. TH302 has not yet been proven to be safe or effective, and any claims of safety and effectiveness can only be made after regulatory review of the data and the approval of the labeled claims. Proposed
Increase the volume?
of solid tumors is typically composed of cells with varying degrees of oxygenation, depending on their proximity to the local blood supply. O2, a small molecule hypoxia-targeted investigational study drug. The highly
Worked in practice. Yeah, worked in practice. It sounded beautiful at first.
mutating to drug metastatic potential. Conventional chemotherapies target actively dividing cells in normoxic areas and cannot easily penetrate the hypoxic zones. These cells are therefore less susceptible to typical anti-cancer therapies. TH302 is a hypoxia-targeted drug that penetrates through normoxic regions as an inactive prodrug and is selectively activated within hypoxic cells. TH302 is converted to its active form, releasing the cytotoxic effector and causing DNA damage to the tumor cells and cell death. Preclinical data suggest that the cytotoxic effector may diffuse to areas outside the hypoxic regions to exert a possible bystander effect and possibly exhibiting additional anti-tumor activity.
Thanks, Greg.
All information in this video should be considered highly confidential.
Understood.
We are going from treatment, all these sorts of things. It's nice.
Okay, I would like to continue with a few comments on how one could use this. Well, we can go back to the slide. Yeah, this proposed mechanism of action to open further opportunities, further scenarios of development. So let's assume we have a drug that really follows this postulated mechanism of action, being activated here more in the hypoxic zone of tumors. What would be typical combination partners for such a drug? Well, one is obviously, so if the drug is more targeting here the hypoxic compartment, it would make sense to combine it with drugs that are more targeting here the oxic, the normoxic compartment. And that's sort of standard therapies like doxorubicin, gemcitabine, cisplatin.
It can't work. I want to ask two questions, maybe without full question, I don't know. The epoxic, the TH302 can't work together, can't work alone. She has to be synergism with chemotherapy.
So the initial phase 1 data clearly show that under these, let's say, standard conditions, the patient with a tumor, in this case these were advanced tumors, clinical activity is evident, yeah, in a couple of, in a range of tumors. Yeah. So the drug per se does have standalone under the sort of standard conditions under which a tumor is growing, it does have activity, anti-tumor activity per se.
What is the correlation between oncologic and hypoxic cell?
That is a very good question. So you're asking, if you go the next step, then the question you're asking is, do we have any biomarkers that would indicate hypoxia, and could we correlate these with, for example, clinical effects of TH302? This is obviously one of the most burning and most forward-looking questions. We're working hard on that, and with my last slide, 2 or 3 slides, I will give you an outline of that. Regarding the question, how can we determine hypoxia in patients? The one option is, as I've initially shown with these stainings in tumors. This is obviously not an appropriate way to do that in humans. Unfortunately, at the current time, we don't have a biomarker that would, for example, in the peripheral blood, soluble whatsoever molecule, that would indicate the degree of hypoxia. So we're working on that, but currently nobody has one.
If you will find it, you will have it in all the tumors.
One of the other options is trying to use sort of dyes like pimonidazole shown in the beginning. And the question is, can we sort of visualize that in a patient? And the answer is perhaps, and that is where Dr. Salim and co-workers are working on, and I'll give you one slide. Oh, let's have a direct look at that. So this is an experimental information that's been obtained by staining, in this case, lung tumor, two different lung tumors, with an experimental compound that is also being modified by hypoxia and which can be visualized by PET imaging. So a greater degree of staining is represented here by a shift towards the red spectrum, and low degree of conversion is more to the right angle. And what can be seen here is in example of a lung tumor, one tumor which has apparently greater areas of hypoxia compared to, well, this is the tumor here, to a tumor with only a low degree of hypoxia. So this is one of the sort of paths where research towards identifying hypoxia biomarker is currently going forward. Salim, would you like to comment on that?
Yes, I think the problem is we do not have soluble biomarkers, and because of the heterogeneity in tumors, molecular imaging is a good thing. Biopsies are difficult. Pimonidazole and carbonic anhydrase 1,9 is difficult. So one of the areas we are looking at is to use PET imaging itself to pick up areas of hypoxia. And if we can identify areas of hypoxia and validate that, it may be a good companion to marker area.
So we're very grateful. We're having this collaboration, and we can use, we can also apply this type of investigation in some of the select maestro patients. Yeah, just quickly coming back to the potential combination partners. So one of the options certainly is to combine with compounds active here in the normoxic anti-tumor areas. Of course, another option is if we could increase the hypoxic frequency or part of the tumors. So typically this would be tried to achieve by blocking blood supply. So anti-angiogenic agents, VEGF antibodies, for example. Yeah. This type of, or TKIs that are anti-angiogenic. This is obvious. And the third one, if you remember the first slide, I didn't go into all details, but the ultimate reaction by which the bromo isophosphoramide mustard leads to cell death is by DNA cross-linking. So also agents that would be synergizing with DNA cross-linking would also be expected to be synergistic with TH302. So these are basically the strategies. Talked about the combination with the normoxic active agents. I talked about the, I mentioned the anti-angiogenics. And the third one is DNA damage sensitizers, for example, here CHK1 inhibitors. So these are all areas where TH302 is currently trying to be developed, trying to be clinically explored. I'll skip this one. And just summarize the current status of clinical development with this slide and the next slide, which gives an overview on the currently open or completed clinical trials with TH302. So there's a couple of clinical entities. There's, for example, soft tissue sarcoma here in the beginning. And the rationale for that is sarcoma is one of the tumors known to have a high frequency of hypoxia. And the standard of care here is doxorubicin. So that's one of the theoretically preferred combination partners. For pancreatic cancer, this is here the phase 2 trial. This is also one area of interest. Yes, non-small cell lung cancer is also on the list, right? If you go further down, you find combination trials here with sunitinib, for example, here with bevacizumab, pazopanib, or sorafenib for lung cancer. Second line treatment option for non-small cell lung cancer currently still is in wide areas of the world, pemetrexed. So pemetrexed had been evaluated in a phase 1B trial where TH302 was combined with either doxorubicin, docetaxel, or pemetrexed, and recommended phase 2 doses have been obtained. And these are then resulting in currently in phase 2 and phase 3 trials in sarcoma, non-small cell lung cancer, and as we are here today, pancreatic cancer. And here, this is the last slide. This is about the pancreatic cancer development. So for pancreatic cancer, we're currently here for the MAESTRO trial, which is a registrational phase 3 trial to establish the efficacy and safety of TH302 in combination with gemcitabine. Similar trials are ongoing in Asian populations, like in a Japanese trial. There's also a phase 3 pan-Asian trial with focus on China being prepared. And further clinical trials are here the imaging trials that are planned to be conducted in MAESTRO. This one here, HX4PET, that is the one which is being conducted at Imperial and in Manchester. And there's also clinical trials being prepared in biliary tract cancers or in PNET tumors in combination with sunitinib. So that is basically where we currently stand and try to summarize in 20 or so minutes both the biological rationale and the clinical development of TH302. And I think stop here, take any questions.
Hi.
Sorry?
Martin, I have a question. What actually happens to the hypoxic tissue after you treat? Does the hypoxia change? Two reasons. One is if it changes, then radiotherapy is another thing you may wish to consider because hypoxia is causes radio resistance.
Right, yeah. Good question. We don't know exactly.
Okay.
Yeah? Because obviously, what you really would do to exactly determine the degree of hypoxia, you would need to somehow look into the tumors after treatment, yeah? Which is currently not being done. Substance is currently being evaluated just clinically in the indications I've shown you. There's another clinical trial in malignant melanoma ongoing where we're trying to address exactly that question, where we're doing serial biopsies during treatment. No results yet.
Okay.
Obviously, another method to address that question is by
Imaging.
very obvious. Yeah.
And what's happening to the cells, to the tissue that is with full oxygen, without hypoxia, and you get the material against the hypoxia?
So what we know from preclinical experiments is that in the tumors, in the murine tumors, there's some bystander effect. So there's also some effect against the more higher oxygenated parts of the tumor. What exactly the detailed mechanism of that is not clear. It may be, for example, local diffusion of the isophosphoramide mustard into the more normoxic regions. Yeah, it may also be a low degree of spontaneous conversion of the inactive prodrug into the active drug under less hypoxic conditions. Yeah.
And what do you think is the mechanism of the skin toxicity?
So we think it's to do with hypoxia.
You do?
Yeah. So if you try to analyze standard normal skin with these pimonidazole stains, you will find hypoxic regions in the skin, and there is some. There's a good possibility that these hypoxic areas correlate with this skin toxicity that's observed in the clinical setting.
Particularly in areas where there's skin folds, right?
Right.
Do you have any data regarding LDH level?
So you're asking for LDH as a marker for tissue necrosis?
Yeah.
Yeah.
If
This is
if there is some
yeah.
sign of activity, of different activity in a patient with LDH high or low.
Yeah. LDH is much too unspecific for that. Yeah, it's such a summary of so many different processes in the tissues, and it can even simply be a tumor marker. Yeah, in terms of high tumor load, we all know that. Yeah, so we don't think this is would be a good parameter for that. So we haven't looked into the details of that, but from the clinical data we have no indication that there is some relation to the TH3.
Because there are very interesting data regarding the use of bevacizumab and which works better in patients with high LDH level. Oppositely, regorafenib seems to act worse in patients with a high LDH level. So I mean, I think that it could be interesting to look at in deeper details.
So in the phase 2 data, I think this has been looked at, and there was not a gross effect, but much more interesting will be the phase 3 data than from the Maestro trial, for example. Yeah, I agree. Yeah?
And have you got any data, the use of combining of TH, or this drug, with such local regional treatment? I mean, microwave, radiofrequency, or the... Okay.
Not yet. Okay, I think we can proceed then.
Yeah, why don't you continue, and then we'll take the break after Martin's.
Okay. So,
phase 2.
okay, I think we try to postpone that. So just following up, so you've seen the phase 1 and phase 1b data. Based on obtaining a recommended phase 2 data, phase 2 dose when combining TH302 with gemcitabine, phase 2 trial was initiated in pancreatic cancer, where the recommended dose that came out of the phase 1b trial, this is the 402 trial, which revealed in the combination with gemcitabine the current dose of 340 milligrams per square meter. So that triggered the conduct of a phase 2 trial, a medium-sized, roughly 70 patients per arm, which already has the same target population as the current Maestro phase 3 trial. So these patients, a total of 240 patients, were randomized to either receive standard gemcitabine or an intermediate or a high dose of TH302. Of note, this was an open trial, and crossover of the patients after disease progression was stipulated by the protocol. This is the treatment schedule. This is the same as you've seen as it's in the Maestro trial. You know that. And very briefly, this is the primary endpoint outcome for this trial. Primary endpoint was progression-free survival. And you see here the three curves. The black one is the control curve, gemcitabine alone, with a median PFS of 3.6 months. And with the 240 milligram dose of TH302, the median PFS was 5.6 months. And with the 340 dose, it was 6 months, which was statistically significant with a hazard ratio of roughly 0.6. Response rates, here, it's reflected here. With the 340 milligram dose of TH302, there was a higher rate of PR and complete remissions, altogether 26%, compared to 10% with gemcitabine only. This is also, if you ask for subgroup effects, this is the forest plot for the various baseline parameters. And obviously, there's nothing peeking out to the right. So there were no subgroups that had a specific benefit or specifically no benefit from treatment within this medium-sized phase 2 trial. If you would like to see the survival results, these are here. And because of the crossover, they are much less impressive than the PFS data. So in the control arm, the median overall survival was 6.9 months, and with the 240 and 340 milligram dose of TH302, it was 8.7 and 9.2 months. These, the hazard ratio was not significant here, and the explanation for that is there was substantial crossover from the gemcitabine-treated patients after disease progression. So basically, this is the efficacy data that the current Maestro trial, where you are all contributing to, is built upon. What about safety? So I mentioned already, clearly TH302 does have some mucosal and skin toxicity. In the phase 1 trials, there was no dose-limiting bone marrow toxicity obvious. So there was relatively low degrees of neutropenia, of bone marrow toxicity. When it comes to combination, like here with gemcitabine, there was an increase both in neutropenia and thrombocytopenia, which is also observed in the other currently being used treatments in pancreatic cancer. So if one compares the toxicity profiles of either FOLFIRINOX or nab-paclitaxel, gemcitabine mono here, versus the combination of gemcitabine plus TH302, the following conclusions can be drawn. With respect to neutropenia, the degree of bone marrow suppression is in the same range as for FOLFIRINOX or a combination of gemcitabine and nab-paclitaxel. For thrombocytopenia, there is a greater suppression in combination with TH2 than with the two other regimen. Overall, febrile neutropenia is in the same range as for FOLFIRINOX or nab-paclitaxel combinations. Other side effects that are much more frequently, and this is grade 3, 4 only, observed with either nab-paclitaxel, like fatigue or neuropathy, are both in a higher frequency present in FOLFIRINOX, and there's practically no grade 3, 4 toxicity here observed in the phase 2 trial. Also for diarrhea, this is not very meaningful, but of course the rash, that is something which seems to be much more frequent with TH302 treatment. So that is the safety profile. Just putting the efficacy data that I've shown you before in the context of the currently available phase 3 data. So we've heard from Professor Trojan about the results from the FOLFIRINOX and the nab-paclitaxel phase 3 trials. And if we compare the phase 2 data that I've just shown you with the phase 3 data from the Prodigy and MPACT trial, first of all, it's notable that in the gemcitabine control arm, the observed survival and response data are very similar. So median overall survival is 6.9, 6.7, PFS 3.7, 3.6, so that's all very close together. Now the hazard ratios that are being observed in favor of the experimental regimen here for progression-free survival, for example, here for nab-paclitaxel is 0.69, for FOLFIRINOX was 0.47, and as I've shown for TH302, it's 0.52. So there is a good indication that at least the phase 2 data are compatible with the increase in benefit in a similar degree as it's been observed in the 2 other trials. And I think this is the summary slide. Just what I said in terms of efficacy. So we do observe in this phase 2 trial an increase in the PFS, in the median PFS from 3.6 to 6.0 months. Increase in the response rate. I didn't comment on the CA99. And the median overall survival was non-significantly prolonged from 6.9 to 9.2 months. And I discussed the safety properties of TH302 observed in this phase 2 trial. So that is where we stand today. And actually, we are already a bit further because you have also already contributed to accrue even already in the 3-digit range patients into the Maestro trial. And I think that I'll take any questions for the phase 2.
Any questions or comments? No?
Is there a correlation with cutaneous toxicity?
So the
Skin toxicity.
yeah,
Skin toxicity.
So the question you're asking about a correlation
and activity, yeah.
Yeah. The answer is no. No, we don't see that.
My question also addresses skin toxicity and stomatitis. Did you also have those kind of strict measurements which we have in the phase 3 and the phase 2 concerning to avoid skin and toxicity and stomatitis?
You mean the supportive
the supportive measures?
Exactly. So these were developed during end of the phase 1 and were implemented while the phase 2 was ongoing.
Okay.
Yeah? So the skin toxicity rates in the phase 2 trial are in between. They are partially addressed by supportive measures like we are now recommending it to, within the phase 3 trial. So it's a bit, if you want to ask what is the effect of that, it's not easy to detail.
Martin, I'll just say a few extra words around that in the development of the skincare products for TH302. Threshold in the early phase trials, Threshold is our partner that we're working with to develop TH302. In the early phase trials, they had discovered that some sites were having problems with skin rashes, but others were not having any problems at all. And the sites that weren't having problems actually had already started to implement some of these skincare products or treatments. So that's how they discovered that these patients were doing much better if they were prophylactically treated with like Desin or Preparation H. So Threshold started working with Dr. Lacouture at NYU in New York City. He is a dermatologist who is essentially devoted his life to helping and treating oncology patients that have skin issues. So Dr. Lacouture helped Threshold develop some of the treatment algorithms in the skincare product that we've currently implemented in the TH302 programs, particularly the Maestro trial. So we've actually provided you his book. It's a gift. It's educational gifts so that you can read up a little bit more about skincare, which is just good practice for any patient that's on a chemotherapy, right? So what we're asking you to do.
You have all the TKI and ALK and GFR.
Yeah. Yep. So what we're asking you to do on threshold for TH302 is really just good practice for all oncology patients.
Right.
Okay, let's take a break for 10 minutes, and then we'll come back and convene then. So I'm 1:45 the hour starts.